Okay, 4.2, zeros of a polynomial function, day 4. In this video, you will see the use of the rational zeros theorem to find all possible zeros of a polynomial. This kind of wraps up this entire section. We did it in chunks. We did a little bit at a time. We started talking about synthetic division. We started talking about long division. We have our rational zeros theorem, which is our P's and Q's. We know how to factor, so we're going to put all of that together to find all zeros of polynomial functions in this video. So let's take a look. Alright, letter H. I ask you to find all the zeros of that function, x to the fourth minus x cubed, yada yada yada. So I ask you to use the rational zeros theorem to list all possible real zeros. Remember, right now, there are infinitely many possibilities. Think about how many are possible. Well, I know it's x to the fourth, so there better be 4 zeros. Right now, I don't have any idea. Right now, there could be infinitely many possibilities. I don't know how to narrow it down. Remember, your rational zeros theorem, that helps you narrow your list down a little bit. So remember, rational zeros theorem, what we do is we take our p's divided by q's, right? We take our p's and q's. So the p, all the factors of that constant. So all of the factors of this positive 12. Well, let's think. What are all the factors of positive 12? Well, 1, 2, 3, 4, 6, and 12. Please do not forget the plus or minus. It always has to be plus or minus, right? Because I know I could do like negative 12 times negative 1, and that gives me positive 12. So that's why it can also be plus or minus. Think Q's, what are they? They are the factors of my leading coefficient, which in this case is a 1, so that's pretty easy. So now, to do our rational zeros theorem, remember, what we have to do is do that division. P divided by Q to get our list. Okay, so we've gone from infinitely many possibilities down to that many possibilities. Think 1, 2, 3, 4, 5, 6 times 2, there are 12 possibilities total. So I've taken you from infinitely many down to 12. I think that's a fair deal. So now I ask you, and I'm going to always have you do this, I'm going to kind of give you a little bit of a hint. In the second one, I'm going to ask you to find all possible zeros, but I'm going to let you use your graphing calculator to narrow your list down. So let's think about what I'm asking you to do. So first of all, I know to find all possible, there should be 4 of them total. So how do I find them? Well, what I'm going to do is I'm going to go to my graphing calculator. So if I think, let's go to my graphing calculator, I'm going to type in that function there. Okay, so I go to my graphing calculator. You'll notice in Y1, there is my function. What I'm going to do is I'm going to hit graph. Remember, if you're not looking at a standard window, you want to hit zoom 6. Okay, so now I'm looking at there's my function. So I said you're allowed to use it to figure out a possible hint. Well, if I glance to the right and I look at my function, it looks like it crosses the x-axis at positive 3. So I think that's the hint I'm going to use. It looks like positive 3 is a zero of my function. So when I go back into my notes, I'm going to use positive 3 as a 0. So we know there should be 4 of them. So what I'm going to do is I'm going to use positive 3 as my 0. Alright, so I know when I do my synthetic division, I always have to check, is there anything missing? Well, to the fourth, to the third, to the second, it looks like nothing's missing, so I'm ready to write my numbers out. From there, what I'm going to do is, well, you should be able to do synthetic division at this point. So bring down that first term, multiply, add. If it's a 0, obviously you should get a 0 remainder. So I know so far that positive 3 is definitely a 0 of my function. Alright, so what I'm going to do from here is look at what I have left. Well, I have my remainder, my constant, my x squared, and my x cubed. I'm going to write that out to see if I can potentially factor that. So there it is. Well, I have 4 terms. I know in order to factor this, I'm probably thinking 4 terms. I'm going to try to factor it by grouping. So let's try to group those. What can I factor out of the first group? I can factor out an x squared. What do I have left? I have x plus 2 left. What can I factor out of the second group? What would I have left? Okay, so it looks like I can definitely factor this by grouping. So let's keep going. Put those together. Well, you should be saying to yourself, well, Mr. Whitehouse, I know we're not done, because that is not linear. Right, we talked about it last week. The linear factorization theorem says that we can break down everything so it's linear. That is not linear, so that means I can take that one step further. Watch this. Let's pull that out to the side. And let's solve for x. So if I break that down, it looks like I get x equals plus or minus the square root of 2. So if I try to factor that from here, well, x plus root 2, x minus root 2, that looks like how I should be able to do that. I'm going to tack on that x plus 2, but be careful. Sometimes I might ask you, well, tell me what the completely factored form would look like. Think about that. Completely factored, there are your three factors, but you know that there should be 4 factors. Where is the 4th one? How do I get that 4th one? Well, you should be saying, well, that 4th one has to come from this guy right here. How do I do that with the positive 3? Well, I know that what I'm going to do is I'm going to tack on the x minus 3. Okay, so if I do that, I know I'm now ready to find my zeros. Think about it. What are your zeros then? And I'm going to kind of write it right over my arrows here. My zeros would be plus or minus root 2, negative 2, positive 3. I said that there should be 4 of them. Guess what? I found 4 of them, and voila, I am done. Okay, so I took the first one really slowly. I'm going to take the second one really slowly as well, and then I'm going to zip through the third one. Hopefully you'll be able to figure this out. Okay, so letter A, second one. Rational zeros theorem to list all your possible rational zeros. So your P's and Q's. Think factors of the constant, factors of the leading coefficient. Divide all your P's by your Q's. There is your possible rational zeros list. Okay, so there are all the possible rational zeros. Okay, so let's go back for a second. Watch this. Remember, we talked about those are only your rational zeros. Take a look. Let's go back to this one here. And notice that, here's something I want you to notice. I'm even going to put it in red. Notice that the negative 2 and the positive 3, they were all in this list. Why was the square root of 2 and the negative square root of 2 not in that list? Well, you should be saying to yourself, if it's not in the list, that must mean that that square root of 2 is irrational. It can't be written as a fraction, and therefore that's why it's not on the list. Okay, so just wanted to back the train up, make sure you understood. That's why it wasn't on the list. Okay, so back to where we were. You had all your P's and Q's, we had all this stuff written out. We had our list. Okay, so it says use this. This is how I'll ask you these questions. Use the information and tools of this section to find all zeros of your polynomial. Well, you should be saying to yourself, okay, I know what I want to do is go to my graphing calculator. So let's go there. And now in your y equals, notice that I pre-typed them all out. So remember, if I can unhighlight the first one, go down and highlight the second one, and now graph that so you can kind of see what I'm doing here. Alright, so it looks like there is my picture. I don't know. Looks like that positive 2 could be 1, but it looks like that negative 1 where it crosses the x-axis, it looks like that's definitely 1. So I think I'm going to probably start with that one. I think I'm going to start with using the negative 1 as my possibility. Okay, remember that there should be 5 total, right? It's x to the 5th. So watch this. Let's use the negative 1. Do your synthetic division. Voila, I get a 0 remainder. Okay, so here's what I want you to think about. Think about what we have left. I have remainder, constant, x squared, x cubed, and x to the 4th. Unfortunately, we can't group them because it's x to the 4th. There's more than 4 terms, right? There are 5 terms there technically, so I can't factor that. So what we're going to have to do is we're going to have to do synthetic division again. But this time I'm going to do synthetic division with what I have left, right? I'm not going to go back to the beginning. My whole goal is to break them down. Right now I'm down to an x to the 4th. If I find one more 0, then I'm down to x cubed, which then I might be able to factor it by grouping. So I'm going to go back to my graphing calculator, and I'm going to find another 0. So we talked about it before. It looked like positive 2 was that other 0, so I'm not going to go back to my graphing calculator. You can kind of look at that on your screen. Looks like positive 2 might be the next 0, so that's what I'm going to test. I'm going to test positive 2 with the numbers that I have left. Notice that I crossed the 0 out. It's not necessary. Okay, so let's try to do our synthetic division again with the numbers that we have left. Lo and behold, look at that, I do get a 0 remainder, so I know that that is a factor as well. Or it is a 0, I'm sorry. So think about what we have left. I think, yeah, I'm absolutely going to be able to, if I look at that, I'm probably going to be able to factor that by grouping. Just be careful. Group them. What can you factor out of the first group? X squared, right? You have 2x plus 3, but look at the second group. You can't factor anything out, but the 2x minus 3s are going to match up, so watch this. Technically, I could factor out a 1, and it's still the same. It's going to be 2x minus 3. So now I can group them, take that one step further. Okay, again, think about it. X squared plus 1. Pull that to the side and actually solve it. Write them as linear factors. Okay, so there are 3 of them. I know that there should be 5 total. Where would the other 2 come from? Well, hopefully you're saying the other 2 would come from here. So tack on those other 2. There is my function completely factored. And now write your zeros. Look at that. Plus or minus I, that's 2. 3 halves, that's 3. Negative 1, that's 4. Positive 2, that's 5. Take a look. Some ways that I can double check myself. 3 halves, that can be written as a fraction. That better be in my list. Well, there it is. Negative 1 can be written as a fraction. That better be in my list. There it is. Positive 2 can be written as a fraction. It better be in my list. Well, there it is. So it's kind of a way you can tell. If you get something like if I would have got 5/4 as a fraction, but it wasn't in my P's and Q's, guess what? I did something wrong somewhere. That's good news. Bad news is now you got to figure out where you went wrong. Okay, so last one. I want you to try it. Pause your video and give it a shot. See if you can do it on your own. Once you come back, I will zip through this last one because I'm already at my time limit. I don't want to go over any further than this, so let's get to it. Your P's and Q's, there they are. So my list, not bad, 8 possibilities. Head to your graphing calculator. You'll see that positive 1 is a hint. Guess what? That worked. What am I left with? That's what I'm left with. Again, this is your guess and test method, your slip and slide method, or the other method that I showed you the other day. I kind of like that, what I did the other day, so I'm going to do that again. I know all the factors of 3x squared are 1 and 3. All the factors of positive 2 are 1 and 2. So I know it's got to be those numbers somehow. So I'm thinking 3x and x. Remember, what we're thinking of is your outside and your inside. It's got to get a 7. So I know it's got to be 6 and 1. So it's got to be plus 2 or there. That gives me 6x on the outside. And it gives me positive 1x on the inside. There is the 7x that I was looking for. Okay, so how to factor that? There are all 3 of them. And voila, there are my zeros. Okay, so I know, rough. 3 problems. The video is a little bit longer, but I thought we needed to see all 3 of these at once to kind of get an idea. We needed to see a bunch of them. GOOD, JOB.